weeks ago, we gathered to hear from some citizen scientists and scientists about the extraordinary contributions that citizen scientists make to their projects. Today, we're going to hear more stories of contribution, but specifically contributions to peer-reviewed publications by citizen scientists. I realize I am talking to the choir here. Most people on this call will know more than I do about publishing scientific literature, and I think it's worth to pause and consider why we publish. Scientific literature is it's the very stuff of science. It's the ultimate product of research. It's the means by which ideas are put out into the community to be tested, to influence others, to be challenged. They stand for tenure, they are legacy, and they're the record of thinking in a scientific community. And if we want to include citizens, the interested people in the public, in science, which everyone on this call does, you're here, including people in publishing is the ultimate form of inclusion. But it's a really involved step, right? It's not just about presenting ideas clearly in a publication. It's presenting and contributing ideas into the flow of scientific exchange. So as Davy Kirkpatrick, who's one of the scientists with the Backyard Worlds Project says, science literature is a conversation. It's a conversation in which each paper serves to establish a point of discussion, not knowledge forevermore. So to engage in this conversation, you need to know and understand what's come before you. You need to know what's going to be an interesting contribution to make to the conversation. There's a lot involved. There's a lot to know. There's a lot to know how to do well. So we're going to hear today some stories from scientists and citizen scientists who have successfully navigated this space. And we have a chance to hear from them what has worked for them. There are some emerging best practices. A couple of them are. One, and we'll maybe hear a little bit about this today, it's good to recognize as a scientist leading the project that your citizen scientists will arrive at your project with a variety of life experiences, from long careers in other scientific fields, and they're coming to your project because they're interested in returning to a childhood passion or interest. So they may have extensive knowledge from another field, which may or may not be perfectly applicable because the publishing practices across fields tend to differ. They may be completely new to scientific publishing, and understanding who they are, what they know, and what they need to know to be successful is going to be an important first step. The second thing that we know is that it's essential to have clarity up front about the roles, the commitment, the nature of the collaboration, the timing, the competing priorities. Citizen scientists are people with lives. Scientists are people with lives. Each have competing priorities for their time, and they're making decisions on the flow about what they need to do and where they need to spend their time. And when people are working hard together, and writing papers is hard work, it's easy for small surprises and small disappointments to become major sources of frustration. So communication is really, really important. Publishing is also something that publishing with citizen scientists is something that NASA is really eager to support. There's so much to be gained for everyone. So Marc and I are working on tools and resources, including sharing best practices from conversations like today's across the community, to help support and help more projects succeed at publishing with citizen scientists. So we would love to hear from you what kind of support you're looking for, what ideas you have, what resources you can offer. So please get in touch. We do know that there are a few things that will be useful. One, these templates, so volunteer or collaboration agreement templates and code of conduct templates, those are in the works. We're also actively looking for resources that can be used by citizen scientists and scientists alike to share with one another what scientific literature is all about and how to learn about that. And then I also want to bring your attention to some upcoming resources that will be arriving kind of in the field from the Citizen Science Association and a group of researchers who are working with an NSF grant that was called Establishing Norms of Data Ethics in Citizen Science. So this is a team of researchers in partnership with the Citizen Science Association who's been leading an effort to co-create a set of tools to support commitments to data ethics and citizen science. So one of the tools in this toolkit is going to be about the different ways that we can recognize the efforts of volunteers through academic recognition with publications or other avenues like intellectual property or public recognition, financial compensation, etc. So the tools in this toolkit will help people think critically about what motivates volunteers and what approaches to recompense are appropriate for your project. So again, these are not prescriptive, but they're more resources to help you think through some of these challenges. So to today's agenda, we have another large panel of speakers for today. We're going to hear from 4 projects with a variety of stories about publishing scientific literature or publishing scientific findings. I'm going to introduce each pair before they begin, and they'll have about 10 minutes to give us the highlights, and then we'll have time for discussion at the end, including questions from our audience. So get those, make a note of those, and we look forward to hearing, having you be part of our discussion. So these are the prompts that I've given our speakers. They'll have just enough time to kind of ground us in what they're doing. And I want you all to remember that the speakers today are in many ways pioneers. They're doing something that hasn't been done a lot before, this collaborative co-authoring of scientific literature. So there's a lot that we can learn from these cases to help other people follow in their footsteps and to support the next wave of citizen scientists and scientists publishing together. So listen for those gems and let's talk about them in our discussion. So first up, we're going to hear from Rusty Lowe, who is joining us today from Brazil, where she is on a Fulbright scholarship. Rusty wears many hats. She's an educator, a scientist, and a scholar. She's particularly passionate about broadening participation in science. She is a science advisor on the Science Activation STEM Engagement in Earth Sciences Project, or SEAS. And we invited her to speak today because the SEAS program occupies a special place in citizen science. It's as much an informal learning project to introduce high school students to authentic research as it is a citizen science effort. So we wanted to hear from her what a formal program of instruction in science writing looks like. This can serve maybe as a model or a resource for other projects who are looking to teach the same ideas in formal or less formal ways. So Rusty, over to you. And I will stop sharing my screen so you can.
Okay, thank you so much, Sarah. I'm just delighted to be here today, and I wish I wasn't the first because I think I would like to learn from others before I actually talked about this. It's really true that this is something that is very new to me, which is publishing with people that are not my peers in science, but actually working with students and citizen scientists. So I'm on a learning curve too. So what I will talk about today is just what kind of work for us. And we have currently two papers that have been published in the last year, and we have one that is currently in review. Those are our outcomes. And, you know, I think the thing that I would like to stress is that when I was a young scientist, I didn't have a very good model on how to get publishing. Both of my advisors for my master's degree and my PhD were not really excited about publishing with their students. And most are, but I just happen to not have that. And so I kind of had to strike off a little bit on my own. And so for that reason, I'm very sensitive to the fact that I think that it's not as scary as it sounds to write a paper, but I think we have a lot of ideas about publishing that kind of gets in people's way. So what I thought I'd just do is just talk about what worked with us. And then I'm hoping then we'll have a discussion later so I can ask my esteemed panel colleagues how to improve what we're doing. So I'm going to share my screen and let me know if you can see it. And there we go.
Yes.
Yeah, good. So I feel very strongly about citizen science. I think it is the coolest thing that has happened it's cool, especially because it's been being more and more accepted by the science community. It's being recognized as a way to not only obtain excellent science data, but also to engage a broader community in science. And in a country where, well, in a world, I think I should say, where there is a certain amount of dissatisfaction with science, or a fear of science, or skepticism of science, our work couldn't be any more important. And so I really think that people that are in citizen science are really helping us to change that kind of culture that we're in. So when I'm working, and so I'm talking specifically today about the citizen scientists that we engage through the GLOBE program. And we have two ways that we engage folks. One is we have monthly webinars for, I'm on Mosquito Habitat Mapper. We have monthly webinars where we present science, and we also ask people to talk about the science that they've conducted, what things that they have been interested in. And we have a blog that we regularly ask people, would you like to please just talk about your observations? And a blog is a very easy entryway into science publication, because it is informal, it is friendly, it can be as short as you want. And so we do get quite a few of our citizen scientists are willing to write blogs about their experiences. And so when I'm working with the high school students in our SEAS program, which is the STEM Enhancement in the Earth, NASA STEM Enhancement in the Earth Sciences program, and that is an 8-week research project, which is bringing together science mentors with high school students in an opportunity to do a rich, deep, data-rich intern experience. We ask them, as soon as they've found anything, or in a discussion when they've talked about something that is a little bit interesting or new or different, or it really seems like it's kind of going towards the area of being an original contribution, we ask folks, hey, you know, we'd love to feature your ideas on our blog. And so this is a very easy first step towards, I think, building the sense of ability to actually be a science communicator in a more professional way. So I just put up here 3 blogs by different, I think these are all students. Yeah, these are all students, high school students that have written these blogs, just about things that they had done. That's not the end of the project. We asked for these really early on. What are your ideas? What did you notice? What are you thinking about? Why do you think this is important? And we accept all of that. And you know, it's funny because very few people actually take us up on this opportunity, but I think it's about 15%. You know, we have about 50 blogs now, and we've had about, I don't want you to check my math, so I'm not gonna tell you how many there were, but it's about 15 or 20% that have actually written a blog. So that's a great thing. Now, Sarah just talked about the Citizen Science Association, and I'm like, yeah, this is a great thing, because the Citizen Science Association is welcoming not only professional scientists that want to learn about citizen science, or people that are making citizen science opportunities available to the community, but it's also welcoming citizen scientists themselves. And so one of the things here on the left here is that of those students that I have worked with, if they have had kind of an interesting idea, and I think that it might be something that could be built on, I let these five students know that, you know, there was a citizen science meeting coming up, and this would be an appropriate place for them to do a poster. And a poster is like another step from an informal blog to a very welcoming kind of community where they can talk about their contributions as a citizen scientist. They don't have to have PhD after their name to be taken really seriously. And so these are 2 posters that were presented last year at the Citizen Scientist Association. And it really meant a lot to them to be able to present their posters, to talk to other people about their experience, to learn more about citizen science, and to learn more about the science that they were doing. And so that's like, I'm talking here about those baby steps. And those baby steps, allow two things. One is they are building confidence as communicators, going from I'm talking about my science in a informal way to an informal audience to I'm talking about my science in a more formal way to a slightly less formal, informal audience to going to actually writing a scientific publication. The other thing that this allowed is, like probably everyone on this panel, if I write a publication, it's on my own time. And I don't get paid to write publications, and I don't get paid to work with students to do publications. So really my bandwidth for this is fairly limited. But if I can begin to get them excited and begin to develop their skills through them going through these different stages, then we get to a place where we're going to write a publication, write a professional peer-reviewed journal article. And in this case, we let the citizen scientist students know that if they collected all their data, if they analyzed their data, if they did everything they needed to do, then they would be included as authors. And authorship is not just, contributing something. These days, authors also have to read the paper, are usually required to read the paper, make comments on the paper. And so this first paper where we talked about the adopt a pixel model that Peter and Nelson developed and we are using in our citizen science programming, we reported this is a data paper just describing a data set. It was completely appropriate that all the people that developed the data set were in fact recognized as authors, even though they did not actually write much of the content. On a different level, we have these last two papers, which are actually scientific research papers talking about the outcomes of the data that we found. And in this case, we had citizen scientists that had actually contributed to this. One student here, which was Matteo Kimura, he had actually contributed to these posters over here. His contribution mainly, he got very excited about the analysis of data, especially through the use of developing code products and algorithms that enabled better understanding of the data, understanding the shape of the data, accessing the data in such a way that it would be meaningful. Because with citizen science data, you very often have, you have to do some data cleaning, some post-processing, pre-processing to do the work. And so he contributed to that. So in the case of this next paper, what he did is I asked him to write up what he had done with respect to the development of algorithms. And just, he did this as part of, he has to also create metadata, right, for all of the data products that he creates. So in creating those metadata products, we also had them turn them into prose that we could include in this paper. And so that was paper number 2. And then this last paper here, we have 2 students that are involved in the development of this paper. This paper is currently in review. And by now, these students are really quite experienced, having gone through first writing a blog and then doing the citizen science poster, being involved in a couple papers, one not at a sort of a very low level, but still eminently qualified to be authors, second a little bit more. In this one, they actually wrote sections of the paper and also participated very actively in the editing process. So it really was very much kind of a structured approach. A lot of, we have to, students need to develop, a lot of skills, in order to write, and writing is not a skill that comes easily to everyone. And so, but this was a nice structured way that we can get people involved. I certainly would like to get more people involved in publishing. We have, our regular citizen scientists have contributed to our blog, but they have not yet had, I really haven't had the ability to bring them into doing publications. But beyond this, beyond co-creating a manuscript with mentors or with lead scientists or whatever, I also just wanted to point out that these are two of those same students that have gone through these 4 stages. And one of those students was an incoming freshman. So I was not able to get her the free ticket in to doing a high school poster. We had to do this poster in the regular poster session with all the master students and PhD students. And so they presented this poster at AGU, and it was selected as the OSPA Award for Earth and Space Informatics. So this paper was up against master's students and PhD students in being the winner for this award. So in this paper, they wrote everything. You know, they organized it, they wrote the text. You know, we worked with them to make sure it all sounded really good. And, you know, this is one of those interactive things. There's a lot more information underneath that you can't see, but they are now first authors. They've gone from writing a blog to being first authors of a paper that won an award at AGU. And that process was about 2 years. So I think that might be all my time. Am I right? I'm very close to being right. But I wanted to give you just a little example of how I could do this with the limited amount of time that I have. I would like to hear from the panelists to think, how can I scale this up? How can I engage more in this effort? And I think that the really important thing, if that's the takeaway, is that these students in their own research, working with our data, came up with some really cool ideas. They were kind of small. They weren't really ready to be a whole paper yet, but we could put them in a context of a broader paper and help them publish. So I look at that as part of my mentoring job as someone in NASA CITSI who's serving as kind of a leader in this program. So thank you for listening. I'm so proud of these guys. I can't tell you how much, but I'm gonna let you go now, and I'm gonna be listening with open ears to the rest of the panelists today. Thank you.
Great, thank you, Rusty. That's what a way to start us off. And I look forward to the conversation that we're going to have at the end. And you've illustrated so beautifully something that Marc talks about, that one of the reasons why we want to publish with citizen scientists is they make outstanding contributions to our publications, and there's real benefit for everyone. So thank you for making that point so beautifully. So next up, we have 2 people from Backyard World's Planet 9. Jackie Faherty, who's part of the science team. She is also the senior scientist and senior education manager jointly in the Department of Astrophysics and the Department of Education at the American Museum of Natural History. And Les Hamlet, a citizen scientist who's been with Backyard World's Planet 9 from its launch. So Jackie and Les, to you.
Hi, everybody. I'm Jackie Faherty, as you just heard, and I'm going to talk to you about Backyard Worlds. Some of you may have been on last week. I see some of the same faces, so I'll give you a summary again about what Backyard Worlds Planet 9 is. We actually have a lot of participants from it here. Marc Kuchner, of course, here, Backyard Worlds. PI, Hugo, is Hugo on? I thought I saw Hugo. I think Hugo's on here, Backyard Worlds participant. So what our project is a dream project on finding an object that might be closer than, say, the closest star, or an object that fits into the category of Planet 9, the 9th planet of the solar system. And I'm not referring to Pluto. It's that object that might be perturbing the outer Kuiper belt objects as postulated by some dynamical theorists that, and actually an observer / dynamical theorist alongside. There may be this 9th object out there. How do you find such objects? Well, you can try really nice complicated things like a machine learning algorithm on lots of major sky data, big surveys to see if you can find a moving object, or you can take images taken with time between them and you blink them. And that's how Pluto was discovered. It was discovered pretty quickly when they started blinking images. Planet 9's a harder object to find, but as a consequence, if you're spending a lot of time blinking images of the sky over time, And if you target the infrared region, you land upon brown dwarfs. These objects that are in between stars and planets, they don't have enough mass to get hydrogen burning at their core. So they just cool through their lifetime. So when they're hot, you could mistake them for a star, not a big star, just like a little baby star. And then when they're cold, they look like Jupiter. So at the end of their life, when they've aged out, they're super cold, or they can actually form just a little bit more massive than Jupiter. The mass boundary that we use for the brown dwarf definition is somewhere between 13 times the mass of Jupiter and 75 times the mass of Jupiter. Above 75 Jupiter masses, you can ignite the core and get hydrogen burning. So star, good job. Below 13 Jupiter masses is this like stupid boundary where it says that you can't get deuterium burning, which is heavy hydrogen in the core. Okay, so this project has been underway for several years now. I can't remember how many years. A couple.
5 years.
5 years? Do you remember, Les?
Yeah, a little
5
bit
years?
more than 5 years.
2017. Okay, 2017 we started, and we have found so many exciting objects. No Planet 9, but loads of exciting objects. And the objects have ranged from some kind of interesting low mass stars, some interesting low mass star pairs, some fascinating brown dwarfs, some extremely cold, some of the coldest compact objects that have ever been discovered, and that are the remnants, the basement of what can happen through the star formation process. And citizen scientists have helped us discover those objects by blinking images. And Les is one of these amazing citizen scientists that has been working with us on blinking images, and then carrying on with their own kind of interested side project survey to find something else once they kind of learn from the research team. And this is all about publications. And so this has been a really intriguing process from my point of view as a researcher to pair off with some of the citizen scientists to figure out how we can get publications done together, where the citizen scientists feel super enabled. They feel like they have control over the field. They understand what's happening so that they can write this paper, because that's not that easy. You know, like I just had a student in here, he's writing his first paper, and it's a hard process. How do you write your introduction? How do you know that you know enough about the field to write it? And so we go down this process of having a lot of conversations. Once a citizen scientist in Backyard Worlds has come to us, or we've kind of like gone back and forth enough on a project and said, we've found something really interesting and you've done a lot of the work. And so I want to dedicate my time to you to get you to the point where you can have that first author moment, ownership of the result. And it's a shared ownership in many ways, publications, but it feels really good when you can put your name on the text and feel like you understood top to bottom everything that was in there, the figures, the tables, you understand the background and all of it. And so in Backyard Worlds, we've done this many times. I think Les has some slides that he's going to show you that has some of the summaries of the papers that we've produced. But the way we've done it in Backyard Worlds is very much like core team scientist pairs with citizen scientists that has an interest. And then we kind of go off and work on it together. And then we bring the team back in order to discuss. And I treat it very much like I treat working with my grad students or undergrads that have come up and done enough where I'm like, you guys are solidly in this. Because this is a reminder that the scientific process is for everyone. You don't need a PhD to write a paper. Anybody in the world, anyone on this call can write a scientific paper with the right guidance, because there's definitely a format, there's definitely rules, there's definitely ways to do it well. And our goal is to produce amazing results alongside citable things that the community should have. So the last thing I'll say on this is that we also start our citizen scientists usually with a research note, which is where Les is right now in the process of creating his first research note. And then the research notes are pretty simple, ease in, like put your foot in the water, you're getting good before we go into the deep end of a full-on astronomical astrophysical journal paper or a lengthier product. So Les, why don't you tell them your thoughts on this and where you think the process has been for Backyard Worlds?
Okay, I'm going to share a document real quick that kind of goes through what I'm going to show, but it has links to various things if you wanted to follow through there, look at it afterwards. I'm going to share my screen here. Okay, can everybody see that? All right, so Backyard Worlds has 15 peer-reviewed publications so far. That's what the NASA site says, so I guess I'll go off of that. I think some of them are republications, at least one of them was. Anyway, it's from what I've learned, it's a definite long process that you have to go through. It seems like a lot of times they're talking about papers for months, if not a year or more. With Backyard Worlds, we have so many good objects that we're having a hard time finding people to publish them. And this is the papers that I personally have been a part of. Turn Coda is a high school student who did a first author paper, and that one was pretty special just because he was a high school student, and I can't imagine doing that at that age. And the next one was the Davy Kirkpatrick's mass function paper, and it's kind of a benchmark paper where people are going to cite it for a long time. The next one was Aaron Meisner's Spitzer follow-up of brown dwarfs, and it's cool just because it was the kind of the last hurrah of Spitzer before it was decommissioned. And these are kind of special just because they were done by high school students. Again, Tarun, and I kind of have a interesting story about that paper. I was part of it. I discovered one of the objects, or co-discovered one of the objects. And in the process of going through the paper, I pointed out that there was better photometry from a different survey. And with that better photometry, they kind of excluded the object that it got me into the paper originally. So sometimes your feedback can get you almost removed from the paper, but I'm still on it. It's kind of an interesting story. And Hunter Brooks, he was a high school student at the time, or in between high school and college. He's actually at Northern Arizona, I believe now. And going back to the research notes that Jackie was talking about, they're kind of a more simple, easy way to get into publishing things. They were launched in 2017, so it's kind of a new thing. They're not peer reviewed or copy edited. You got to have 1,000 words or fewer and no more than a single figure or table. That'll say, even though they're not peer reviewed, when you have people like Jackie and Marc as co-authors, I'd say that's pretty good clout, even though you can do them on your own if you choose. And here are some of the Backyard Worlds related research notes. I'm not going to try and say Peter's last name, but Peter J. He has a research note. Austin Rothermick and Frank Kiwi. And Frank just had a full on peer-reviewed paper published or accepted today. And it's pretty interesting just because he actually conceived of the project, did it all, and wrote it all by himself. Not by himself. I mean, he had help from obviously Jackie and whoever else. I haven't got to read the paper yet, so I still.
Yeah, I'll comment on this one because it's a great example. Frank did come to us with an idea for this project that we were, I was like, definitely a good idea. He had learned a lot of skills with Backyard Worlds learning how to parse through pan-stars data. And then one of our co-founders, Aaron Meisner, works now for Noir Labs. And Noir Labs has this big new source catalog. And we knew that this had super potential for getting co-moving low mass systems discovered. Like a brown dwarf co-moving was something that people don't know about yet. So it's not really the backyard worlds, like under the umbrella of everything of the title Backyard Worlds: Planet 9. You weren't going to find Planet 9 this way. But Frank learned how to do this through us. So when he came to me and he said he wanted to do this, I said, let's do the research note first. And so we worked on this research note, discovery of a low mass co-moving system using Noir Labs source catalog DR2. It was the first paper to use that Noir Labs source catalog in that way. And we knew that through the inside info of Aaron Meisner, who's one of the co-founders. And then Frank was so excited. And also I just saw it and I was like, Frank, this is a paper. And so we then went into the process of let's make this a paper. I will say he was, Frank's not on the call, but he was very trepidatious at first about putting it together, which I totally understand, but Frank was able to produce a draft for me quicker than some grad students produce drafts. And that's a testament to, like, if you're a good writer, actually that spells really nicely in terms of being a scientist already. Like, that's the unsaid thing about scientists. We have to be writers. We have to be good writers if we want our science to be communicated out in the research zone. So, and it's true, Les, as he just said, that paper was actually accepted last night. It might have, it hit the archive yesterday. So Les, so Frank got it accepted. Awesome job. And we put it up on the archive right away. So great process. I
will say I'm actually also doing a project with the NSC catalog, NORLab catalog. So Frank and I kind of collaborated a little bit during the beginning of that because we were kind of the two that were working with that catalog.
Hey, you guys, we're running a little short on time, so
okay.
Finish up and we'll have time for
Q&A. We also have some published software by Dan Castleton, Wise View. We talked about that last week, and it might be the most important thing we've published. And just some skills, tools and skills that you might need for writing a paper, overleaf and LaTeX, and of course making Python, or Python for making plots and figures. And of course, those are almost purposely difficult to learn, it seems like. And just if you're wanting to be a co-author, especially with our project, you're not really into, doing everything yourself. You're pretty much at the whim of the professional scientist. And did your discovery make the follow-up list? I think a lot of people in our project find out that they made the list by being a co-author on a paper. And I'll go ahead and jump forward here, and just patience is definitely required. A lot of the things I was published for, I discovered almost 5 years ago. So it can take a lot of time from beginning to end. And that's all I have.
Thanks, Les. That's all of science too. And I just want to give lots of props out to Les, who's in this process right now of, he shared with me his research note. He's going to be a published author very soon. And then we're going to get you to the full paper stage, Les. You're headed there.
That's great. Thank you both so much. And that was thanks for giving us too a little window into the internal dynamics of a citizen science project. And it's fun to see how much respect you both have for each other and how well you kind of understand what you're all going through and support each other. And it's really nice to see. Thanks for that window. All right, up next, we have two people from the Sungrazers project, Karl Battams and Quanzhi. So Sungrazer is a special citizen science project in the NASA portfolio because it was started by citizen scientists. It's a true story. Karl told me last week. It's confirmed. Maybe he'll tell us all about it a little bit more now. Karl is an astrophysicist and computational scientist based at the Naval Research Laboratory in Washington, D.C., and he's operated the NASA-funded Sungrazing Comets project since 2003. Quanzhi is now a planetary astronomer at the University of Maryland and a visiting researcher at Boston University. When he began with Sungrazers, however, neither of those things was true. So we'll hear about that story as well. Thank you both for being here.
Thanks, Sarah. Yeah, so to go back to your first point, Sungrazer it's a very unique project because it was founded in response to citizen scientists making discoveries rather than a scientist saying, hey, I've got this problem to solve and I want citizen scientists to do it. And essentially what happened is, this is back in like the late 1990s, early 2000s. NASA were releasing data from the SOHO spacecraft online, and a small number of amateur astronomers picked up on the fact that the cameras were discovering or were observing comets. And these guys realized, hey, these are new comets, like we need to start reporting these to people. And so they started reporting them to the SOHO project team. And at first it was just kind of a gentle trickle of reports so they could kind of handle it. But within a couple of years it had caught on, and there were tens, dozens, couple of hundred reports of these comets coming in, and the scientists were like, well, this is, what are we supposed to do with this? How are we supposed to collect all these things? My inbox is getting full of comet reports. And so that inspired the creation of the Sungrazer project, which is a citizen science effort that essentially provides the website and the centralized location for amateur astronomers who want to look for comets in the data. They can go and look for the comets, they can report them to the website, and then it's kind of my role to look through all of these reports and do all the necessary like science measurements of the comets and get them reported to the official agencies that deal with the comets. So that was around 2003 when I joined the project, but the project had actually kind of kicked off. Its web presence began, I think it was late 2001, so a couple of years before I came along. But I've been doing it for nearly 19 years now. And Quanzhi here, he was, I think, I looked it up earlier. It looks like 2005 was when he joined the project, and he found a few comets, but he's really typical of well, I shouldn't say typical. He's a great example of a success stories that we've had with the Sungrazer project, where we've had these young astronomy enthusiasts as teenagers before they've gotten their degrees, like they're maybe interested in astronomy, but they don't know what they're going to do with their careers. But the Sungrazer project gives them kind of an outlet to sort of dip their toes into the water of doing some astronomy. And then, I mean, in Quanzhi's case, he's gone on and gotten his degrees and his PhD, and now he's a collaborator of mine. So we collaborate on science at a professional level. But there's a number of other Sungrazer project contributors that have followed the same path. So I know that the subject of, or the general theme of this this meeting we're having here today is to talk about the publication process. And I actually haven't had a chance to talk to Quanzhi about this offline, so I'm curious to hear his thoughts on it from his perspective. But just as a brief overview, we do have a number of publications that come from the project. We've discovered well over 4,300 comets. There's an awful lot of science in that. So a lot of professional scientists, of course, have used that data to publish, but there have been a number of, I guess you call them amateur. I don't even like to refer to them as amateur because the work they do is professional level, but there are non-PhD contributors who have either written papers or co-authored on papers. And I mean, it's a wonderful, invaluable aspect, I think, of all these citizen science efforts, that there is science there that can be realized and then also published by the project contributors. And I do still think we've got a lot of work to do in terms of getting to the point where these contributors really feel like it's accessible and it's something that is within their capabilities to do. So let me shut up for a minute and let Quanzhi talk for a moment. And I'm curious, particularly like from your perspective, when you were young, when you got into it, like did that, were you intimidated by the publication side of it, the science side of it? Like what was your trajectory like?
Yeah, hi Karl and hello everybody. Very nice to be here. And Karl, nice to see you again.
Yeah, I know, it's a long time.
That we have been for almost 20 years. Though I only meet Karl in person only once at a conference. Well, not really at a conference, but at a coffee shop near the conference that he asked me. Yeah. Well, for me, I think Karl summarized it up nicely. It's like I was a high school in southern China when I joined the Sungrazers. I heard it from my colleagues, other amateurs. They said, hey, this is cool. You actually got to do some real science. Apart from go out and do stargazing and take some pretty pictures. And for me, I think Karl summarized that nicely. That I mean, I had a lot of energy. Yeah, I want to do something. I don't know how to really get into the game and get some hands-on exercise. Well, I mean, people said, oh yeah, you go to college, you go get a PhD, but that feels like 20 years away for a high schooler, right? So I'm really grateful, and I still really tremendously grateful that I come across Sunggrazers, because first, of course, it's like, well, I wasn't really thinking about publication. It's just fun, You have science, you look at pictures, that they come from spacecraft that's million miles away from us, real-time data, and that you're going to see something that nobody else has ever seen. This is all real-time data. NASA make it public when they reach the Earth, and you talk to other people, not just folks in your own country, and also folks in other countries as well. And some are like at similar ages as I do, and now some of them have started have become a professional astronomers, and others they still have intense interest in astronomy, even though they choose not to pursue a professional career. So now looking back, I not only had hands-on opportunity to do science, learn how to do science, like you really explore it without really a set goal, but you learn along the process, you make friends, and you have long-term collaborators like Karl. So yeah, so I think it's a very fulfilling, and I'm very happy that it's there and in it. So sorry, it's kind of like some random thoughts about it. But yes, I mean, it's like a playground. Yeah, you bring babies, you bring kids to the playground. You don't need to tell them, hey, you need to play this for 20 minutes, and you need to come up with some assignments. No, you just go and play, and at some point you start getting into it.
Yeah, and I think that like your trajectory, obviously your trajectory isn't typical. I mean, we have a lot of our contributors, they're not on the pathway through STEM careers. They're not looking to do like PhDs, but I think you highlight a really valuable point about these projects, that you need to make it fun, first of all, make it accessible to all these different ages, so that when youngsters come in, I mean, like, we're really proud that we've had a 12-year-old discover a comet, and we've had a couple of 13-year-olds discover comets, and that's awesome. And you can't have them come in at that age and throw science at them too heavily. Like, it has to be accessible at that level and enjoyable, but there needs to be kind of room for them to grow in that too. And I think that's obviously what Quanzhi's done. I mean, sure, he always had that interest in astronomy, and he's had that career goal to follow the path through to PhD. But I think that the story resonates with all different levels that we have within the project participants.
Thank you both. I'm going to stop you there just because we're running short of time, but you
Sure.
have highlighted something that's come up over and over and over again in these conversations, that the value of having welcoming, fun places where people want to be, making the projects places where people want to gather and are safe, interesting, fun places, supportive places to learn. And I love that point of developing colleagues that last into your professional life, or in the case of some of the other examples today, that just last as long-term collaborations between scientists and citizen scientists. So next up, we have a great example of the latter. So our final publication pair is joining us from JunoCam. Hansen, or Candice Hansen, is a planetary scientist and the architect of the JunoCam and the citizen science effort that's grown around the JunoCam. She's joined today by Gerald Eichstädt, a prolific citizen scientist who's on almost as many papers as Candy is. We're looking forward to hearing more from both of you about this project and your collaboration, where it started and how it's going.
Okay, thank you, Sarah. I'm really impressed at the variety of experiences and how different our 4 different projects are. So I'm going to talk about JunoCam. I'm starting with a little bit of an intro just to set the stage, and then Gerald will take over and talk about his work. JunoCam is on the Juno spacecraft, which is in orbit around Jupiter. And the way we set it up originally, the vision from Scott Bolton, the PI, was that we wanted to offer an opportunity for people to participate in a flight project. And so it was more intended to be outreach. We knew that we would be able to do some science with the camera, but that was a bit of a sideline. And so the science that has come out of JunoCam is really, a lot of it is very much homegrown from our participants. We don't have a traditional imaging team. And so we set up our project to be a way for people to become members of our virtual team. And we set up 5 different portals for people to contribute. I'm going to only say briefly a few things about planning and about image processing, and because we just don't have enough time to go into the others. And those are the 2 that have worked best anyways. So there's the URL, and when we were envisioning this, we really were fairly certain that the amateur astronomy community would be excited. So we set up the planning page for people to upload their own telescope observations from their own backyards. And there are people with amazing telescopes in their backyards. And then with our tiny little ops team, because we don't, like I said, have a real science team, we take those images and convert them into cylindrical maps. And then we use those to plan the timing of our images on any given perijove pass. So the communication, the collaboration with the amateur astronomy community was already sort of baked in, and it's a real pro-am collaboration. And so that part, we felt pretty good about it. Then the other piece is the image processing. So once the images come down from the spacecraft, then we post them, and we post 3 different versions. The raw data, which is in the lower left in this slide, which is framelets coming directly from the camera. Then we do a monochrome reconstructions, and finally a color map projected image. And then the public can come and take whichever one they want to do whatever they want. And we have really fabulous artistic contributions. But the place that we're headed today is to talk about the actual science coming out of the images. So you can see on the left what we post, and we sort of deliberately didn't make it fabulous because we wanted to stop at a point where people could feel like they were making real contributions. And so this is where Gerald comes into the picture, and with the image processing, and then further than that, going on to the analysis of the data and being on papers and writing papers, contributing to papers. And you're right, on Juno, he has almost as many co-authorships as I do. I actually don't have a lead author role on any of our science papers because it has been a real grassroots effort. And I see my job as promoting that rather than mentoring it. And so anyway, let me stop, and Gerald, just tell me, when you want me to advance the slides.
So, okay, so I don't have to share my screen. So first, a few words. Do you hear me? Yeah.
Yes.
For a few words about my background. After studying mathematics and computer science, I worked about 20 years for industry, mostly as a freelance. And in 2012, in the context of the MSR mission, I joined unmannedspaceflight.com, where about a year later, I learned about the Juno mission. And in October 2013, when Juno had its Earth flyby, we got the first set of real raw Juno images. And so I started with the tentative processing. And after that, we had, especially I had 3 years time for software development, including in-flight instrument calibration. Then in 2016, we had our first Europlanet Juno Pro-Am workshop in Nice, France, where I was invited to. And well, after that, I processed almost all raw JunoCam images since Earth flyby. And well, over the years, I joined conference presentations and contributed to writing papers. So next slide. One of those papers was led by John Rogers about flow patterns of Jupiter's south polar region. So since from Earth we see only or look at the equatorial region and see the polar region very poorly. So prior to the Juno mission, the zonal dynamics of Jupiter's south polar region was poorly observed and described. But Juno's near polar orbit made the polar region accessible to detailed observations. Preceding Juno papers discussed the clusters of circumpolar cyclone CPCs. And this paper of John Rogers fills in the gap between the pre-Juno observations and the southern CPC cluster. Maybe if you see my cursor, here's the pole. That portion was described in older, in prior papers, and here we are over closer to the top. We have those portions who are visible from Earth. In the zone in between this bluish region and the brownish zone, this portion was not very well observed. So this paper filled in that gap. So it finds the southernmost jet S6 undulating, hence faster than previously thought, since an undulating path is longer than a straight path, and so those data had to be adjusted. So next slide, please. My contribution consisted of two parts. Part one was the transformation from raw JunoCam images into pairs of south polar maps to make cloud dynamics accessible to visual and to algorithmic analysis. On the left side, you see a typical raw JunoCam images, which consists of framelets, and you barely see anything. So on the right side, it's a blink between two processed images, and they are processed in a way that they are then they are accessible to visual comparison by a blink and also to an algorithmic analysis. At the top of the image, you may see a circumpolar cyclone accompanied by a small anticyclone. And if you have a closer look to details, you'll see that there's a chance to see the dynamics of the clouds. So next slide, please. The second part of my contribution was the algorithmic portion. So in the first step, what you see on the right side, such an image pair is reduced to a vorticity map. Vorticity is kind of a local angular velocity. It's about twice the local angular velocity. And you may see at the left, maybe Candy, you can show on the vorticity map the polar cyclone at the center on the right side. Yeah, that's a south polar cyclone. It's surrounded by circumpolar cyclones, and a little bit right of this, there's the pink spot that's an anticyclone. And you may get an idea of the overall zonal structure of the vorticity profile. And on the left side, this is further reduced to a zonal vorticity profile. There's at the left, there's a peak downward, a little bit right of the 90 degrees south. That's on the left. Do you see that, Candy? On the left, yeah, there's a peak, and this peak corresponds to the south polar cyclone. A little bit right of that, there's another downward peak, and that's yeah, a little bit right of that. There's a second peak, and that's yeah, that's the circumpolar cyclones. And a little and more in the next peak downwards. Next peak on the right, little downward, the downward peak on the next downward peak on the right of that. That's kind of as if there would be an S7 jet, this next peak would be the S7, and after that we have other peaks, downward peaks, which the right portion of which would be S6, S5, S3, S4, and S3 jets. And so we see we can fill in all that gap and analyze the vorticity profile. So can you now switch to the next? Okay, and this is about future topics. You may see those subtle haze structures marked by the lines and the arrows. That's one of the questions we will think about in the future. And then on the next slide, we see very distinct structures of cloud towers and other three-dimensional cloud and storm structures. And with long baseline analysis, we think that we can derive the 3D structure of those convective clouds. On the final slide, we see 5 of the northern circumpolar cyclones, and at the bottom a portion of the northern north polar cyclone. So, and those latest 3 images are all of page 41. That's just 11 days ago. So you're more up to date than everyone else now. And I thank you for your attention.
Wow.
Thank you, Gerald.
And thank you both for that that great introduction to JunoCam, and that those images, they really are incredibly mesmerizing and powerful. So congratulations everyone on your work. Marc, I think you wanted to say a few things before we get into our Q&A.
Oh, I did. Oh, I have so many questions. Okay.
I know.
Really impressive work, everybody. I'm blown away. Okay, here's what I want to say is that NASA's, we love it when you guys publish, when anybody publishes great science. And since we're the citizen science program, we love it when citizen science results in publications, just like, you know, the rest of the science mission directorate. And we have this publications page that Sarah put in the chat before, which attempts to list all the publications that citizen scientists have co-authored. I'm very proud of that, of course. The thing that I personally want to help everybody in our community get to is the state that these 4 projects and outstanding citizen scientists are you know, showing off today, is that when you find magic happens when you find a way to work closely with your citizen scientists and let citizen scientists use their full mental capacity to do science with you. Anything that gets you from beyond just having citizen scientists be unknown, mysterious people out there who maybe click on something or send you a photo now and then, anything that gets you to, you know, harnessing the full intellect of our citizen science community, I'm excited about. That's all. Let's go into the Q&A because I've lost so many things I want to ask.
Great. And by the way, while we're taking a little moment to be on soapboxes, if you are a citizen scientist in this group who has not been profiled on the NASA Citizen Science page, and you are one of the people who has co-authored a paper, I'm dropping a link in the chat. You too, we want to profile you. This is one of my favorite things to do, is to work with the citizen scientists who have co-authored papers, because to a person, I've learned from you, you're charming, you're wonderful, you're inspiring, and it's great to share your stories with everyone else. So follow that link if you don't already have a profile, and let me help you get one on the web pages. Okay, so it is Q&A time. If you have a question, we'd love to see those in the chat. And Marc, do you have a question? And
oh, yes,
Brianna, maybe you can help me pin all the panelists and keep Marc and me pinned as well, and so everyone can see each other. Okay, Marc, go ahead.
Yay. Okay, the first one's for Rusty about the webinars. How do you invite people? What's the mechanics of inviting people to a webinar? Like, I'm used to like Mosquito Habitat Mappers being an app and the participants are anonymous. So how do you get from the like anonymous people, like, how do you pull them into that webinar?
That's such a good question, Marc, and thank you for it. And I think that one of the things that we have with the GLOBE program is we have a pretty strong media presence through the work of the GLOBE communication team. And so we regularly put out announcements that there are webinars that people can go to. We try to make them, we have a little shareable with an image on it that makes it look like it might be kind of interesting or fun. And we, as we've gone through, we've tried to let people know that these webinars, that we put together. Very often we try to encourage our participants to also participate. I'm tired. Okay. But we, the people that are there, we ask people to also talk about what they have done. It's not just delivery of science, but also we try to enjoin kind of a conversation. And so Cassie Sofine, who I think is on this call, is the campaign lead for this. And so she works really hard to get the word out there. But we do use that. We use the NASA media and the Globe media to get people to go to those. We very often, we usually have about, I'm thinking about 50 or 60 people, but today it was 10. So it really differs on what the topic is and if they're interested and things like that.
And then but still they're on the webinar and you still don't have a way to reach out to them, right? Because they're just like behind the screen. Like, how do you, to write the paper, you have to have a jillion conversations back and forth, sharing, drafts, and like, that's a way deeper interaction. You have to know each other's cell phone numbers and the names of your pets. And like, it's really personal. Like, how do you go from the webinar to like that level of intimacy?
That is a great question. And I think that this is actually the question that I wanted to hear, talk to other people about, because I think that what we are suffering from, if you want to call it that, is that I find it very labor intensive to write a paper, and it's very labor intensive, but super fun to work with other people in writing a paper. And so, making those connections is really, really challenging. And it has not happened except in the cases where people have either come up with something that's really super interesting and we've reached out to them and said, hey, would you do a blog on this? That sort of sets the tone. It sort of sets and then you can begin to deepen that relationship. But it really is a relationship, isn't it, Marc? When you're developing a paper or working together, and trying to figure out how to scale that is something I'd really like to work on. So if you have any ideas, I'd love to hear them.
You get their email addresses from the webinar somehow, and then you email them and say, hey, write a blog.
So basically, like, there's a chat going on right now. And if someone has presented something, like today, one of the guys from Nigeria had some interesting things that he had done. And I wrote him and I said, hey, please send me your email. And so, I will contact him later and just ask him about things. So that's really, we have an email list, so we could reach out to everybody and ask them to write a blog, but that's not going to be very effective. But I think that if people, if you can make a connection and show them why it's important, I think that you can begin to build that process.
So it's in the chat in the webinar. You say, hey, you want to put your email in here and I'll reach out to you.
Yeah.
I'm sorry. I'm taking.
No. It sounds pretty bland, but that's really where we are right now. So how do you scale that up? How do you get more people involved? How do you get people wanting to do more than just collect data, but actually, take a look at the data and, develop some algorithms and play with it? It's stimulating that interest is, I think, the hard thing. I think that you guys, these teams here, have talked really, I'm already excited about what they're doing. So yeah.
Nice.
My 2 cents.
I had a question. It is wonderful, this range of projects that we have and the range of approaches that you all have shared to writing. And I've heard, Rusty, you had some great examples of getting citizen scientists started by writing blog posts and slowly writing, and then a poster, and then tackling a citizen or an actual scientific publication. And then somebody else was talking about the research notes. That Les and Jackie were talking about having citizen scientists write research notes and then moving towards papers. I'm wondering a couple things. If there are other approaches that are maybe pathways that could be proven to be kind of useful and good ways for other projects to kind of warm people up to writing. And I'm particularly curious if any of you have engaged citizen scientists as reviewers of manuscripts or reviewers of documents or peer reviewing others' work as an informal or formal way to warm people up to the idea of publishing.
That's a really nice idea. And I can just say from that one paper we were doing, you know, we did ask people to review it and to give us some ideas and things like that. And I think that is a very nice idea, Sarah, that I think that we can then maybe build out. So, wow, you just made this a really worthwhile meeting today. Yeah, I think that's a great idea.
Any other thoughts from the other teams on pathways to warm people up to the idea of writing?
I'll say that with Backyard Worlds, what we kicked around a couple of times was having a boot camp, a little bit of a boot camp on, you know, here are the 101s. So you're not gonna write here. You're just gonna learn, like, what is overleaf? What does a LaTeX command look like? Because that can be a barrier at times. Because once, like Les, you knew how to use LaTeX, which was great to see right away. And you made the overleaf without me having to teach you anything. Can you say how you knew how to do that already?
I Googled it, I think, and looked it up and made an account, and then just kind of started copying off of other papers, I guess, is what I can say. I would go to Davy's paper and see what he used as far as I've really only got through. I haven't really got into citing stuff and stuff like that, but
We'll get there. The bibliography.
Putting all the co-authors on there with all the proper information and stuff like that, and getting the abstract and just kind of the formatting and stuff like that done. But yeah, I think I just Googled it and just tried doing it by myself and figured it out. I saw somebody else talk about there are some Google interfaces that you can use where you can write it in Google Docs, and you can easily transfer it and add citations and everything, and then easily move it to LaTeX. But I haven't tried any of them, so I can't really recommend them. But during researching this for this call, I did find out there were a few of those that are trying to make it easier and more accessible for more people to do it.
I know, listening to you speak, I'm reminded the last event, Jörg shared that projects are well advised to tap their experienced citizen scientists to help train the newcomers to projects kind of on the 101 of the project. But if I were Jackie, I would get you to teach her graduate students how to write scientific papers, because it sounds like you've done a lot of really important legwork to get yourself up to speed. And yeah, it's wonderful what you've learned. Any other comments, or do any of you all have questions for each other? Because this is such a great group of people, and given your experience, you may have better questions for each other than I do.
So I just wanted to answer one of Marc's questions.
Speaking of relationship, sorry.
Quanzhi, let
yes,
Candy go, and then we'll have you. No worries, delays.
So
Okay.
Gerald does not use Photoshop to do what he does. I'm not quite sure why you put that in the chat, but he has written his own software.
That's the point I was making, was Photoshop does not compute those functions that those vector fields that Gerald was showing us. That's exactly what I was saying.
Oh, okay. I thought you were confused.
Okay.
Because you mentioned Photoshop as being a common tool. So I was like, wait, this is way beyond anything Photoshop would do.
Yeah.
Maybe I can add a few words. I've written all the stuff which is usually doing SPICE and ISIS-3, so I've developed all the software from scratch almost. So therefore the whole thing took about 3 years to implement all that, and it's also based on portions of software I've written before, and you have only seen the a small slice of the products I've created on other things, fluid dynamical simulations, and it's also written from scratch and so on, and many other things like camera calibration and so on. So the images are just a tip of an iceberg.
I don't even know where to begin. I'm so impressed with that work, but thank you. And your images are incredible, and you are an amazing example of the incredible contributions that people make to science that these projects invite, and it's gobsmacking to have you with us. Thank you.
Oh, well, that's of course half of the truth at most, because the incredible thing is actually Jupiter and the camera. So I couldn't do pretty much without the raw data. So I'm happy to have this data. Just the software wouldn't do anything.
That's a good point. And kudos to you, Candy, and the rest who had the foresight to add JunoCam to that mission. That's really, it's I'm sure it's producing beyond what you imagined. Go ahead.
Yeah, let me just add one thing that's been important, and it's to not be territorial. And so, in fact, we have really reached out to, unmannedspaceflight.com and to the whole WinJupos gang. And so putting it out there.
Good. That's an excellent point. And coming up, we have the year of open science. So maybe more and more people will be following in your footsteps. Quanzhi, you wanted to say something. And in the meantime, Marc has added a question to you in the chat that hopefully you'll answer as well. So he's wondering how your involvement with Sungrazers impacted your scientific career or ambitions. And then go ahead and share whatever it was you were going to share.
Yeah, to answer Mark's question, I think the most direct impact is to make me feel like there's a way for me to get onto the boat, even though it seems almost impossible to get a PhD from me at that point. It just seemed a very tall order. I don't think it really helped me to get into grad school, for that matter, because for grad school I decided to do meteor astronomy, which is related but not really directly related field. But I think the experience I got from Sungrazer is really not something that can be measured by getting into grad school or something. It's really a big boost to myself, telling me, hey, I can do this. I can do something really fun and become a real scientist. So the thing I wanted to share before is about the relationship. At least for Sungrazers, I see that there are many Facebook groups, several Facebook groups, and there are people active on Twitter. And Karl is really a big star on Twitter. That really helps people connect to each other. For myself, sometimes I connect to others, citizen scientists, myself as a citizen scientist, but sometimes when I'm in like leading a research, I also find that Facebook group is useful for me to approach people that I didn't know before. So I don't know whether other panelists have found this useful, but at least for me, this Twitter, Facebook, and other like Web 2.0 or 3.0 tools are really useful for myself.
Yeah, I think.
Go ahead, Karl.
Sorry, I was just going to say real quick. I think that providing or there being a platform for the citizen scientists to talk among themselves is really important. So one of the other things that happened really early on in the Sungrazer project is the project contributors created their own Yahoo chat group, and that chat group persisted for many years until Yahoo actually recently just did away with those. And so a lot of these astronomy chat groups that were on Yahoo have now transitioned to the groups.io is another chat platform, and they basically created their own little sub forums and their own community around that, and that really allows a lot of engagement and discussion among themselves. And I involve myself in that a little bit, but I also try and keep a little bit hands off in a way too. Like I want them to feel like that's their space. It's not some extension of the project that the NASA official or whoever is like overseeing. That's their space for them to talk and have their own discussion. And if they have questions, I'm happy to jump in. But to me, it seems really important that they have a place where they can bounce ideas off each other and kind of talk at their level and exchange ideas.
Great. We are at the top of the hour. If you have to leave, we understand. If you want to stay and continue this conversation, we could probably talk for hours and hours. So please stay as long as you can. But if you have to leave, you have to leave. And we will turn off the record. Well, we'll keep the recording on for a little while and see what else comes up, because it feels like a great conversation. Marc, I think you had your hand up or you were asking other questions. Thank you, Candy. Thank you so much for being here.
Bye, everybody.
And Gerald, it's late where you are, so we also completely understand if you need to tap out as well.
I'm used to work all the night if necessary, so no problem.
Okay.
I could also extend the answer of the Candice answer about meeting other citizen scientists. So we had meetings in London and we were on conferences, and so we had occasional opportunities to meet at least some of those other citizen scientists in person.
So I'm
If that
curious
ever
about.
happen- hang on, wait. If that ever happens, send me a photo.
Yeah,
About-
pictures of people getting together in person. So I'm curious, and this has come up several times. Are there, do those of you who have in your projects, there's a space for citizen scientists to work together. Do you, have you seen misbehavior? Have you had that be an issue? Do you have codes of conduct that are in place? To what degree have you created structure? And how has that been necessary? Any comments on that? It's one of those things that often you wish you had a code of conduct when something happens, but nothing's happening. So imposing that structure, and I think that's all these projects are in a growth space, and that tension is real.
So I have to jump off in a minute, but I can answer this real quick because one of the unique things about Sungrazer is it's very, very I guess high intensity or time intensive. Like NASA dumped data onto the web and guys, like, they pile on it. And oftentimes people report comets like within seconds of each other, sometimes literally at the same second. And so I have to have rules in place. Like when you report a comet, you need your rules, your report needs to follow these guidelines. It needs to be very strict. I have to make it so there's no chance for somebody to like copy and paste somebody else's report and make that report and try and get like their own credit for it. No one has ever actually done that, but there have been times when, and I won't go into specifics, but there have been times when people have tried to game the system a little bit to try and get themselves a little bit more publicity or stuff like that. It's very rare. Mostly everyone understands that this is a platform for everyone and it's open to everyone and it should stay like fair. But just because of the nature of what we have to do with Sungrazer and the way it works, there unfortunately have to be some pretty strict rules in place at times, which can cause problems. It can ruffle some feathers at times, and it's unfortunately that's just kind of the nature of the beast with the project that we have.
Go ahead, Jackie. And then we
Well,
have
I wanted to follow up on that with what you're saying, because I'm curious what your perception is of why the small number have the like uber competitive part. Is it the classic science ego is everywhere anyway, the thing we see as scientists that our PhD colleagues will do to each other, or is it something else? What are you identifying as a cause root for the bad behavior?
The competitiveness is simply because it's driven purely by the enthusiasm for being the person to get their discovery, to get their name on the comet discovery. I mean, it's literally driven that simply. They want to be the one that says, hey, I discovered this comet. This is my comet. And that's a big motivator, even for me. I've discovered a handful of comets with the project, and the first time I got one, I mean, I had an adrenaline rush for a couple of hours or so. It's really cool to be like, wow, I just discovered a comet. And so that's what's driving them to try and be the fastest to report. So like find the links. Where does the data first get released by NASA on the website? What's the most raw form of the data that I can get and process it as quickly as I can to try and find a comet? And let's see if I can go from 0 to comet report in 1.5 minutes and hope that somebody doesn't beat me out by 10 seconds. It's not an aggression-based competitiveness at all. It's just purely this is really exciting, and I want to be the one to get this. And I know if I'm 30 seconds slower than somebody else or a minute slower, I'm not going to be able to get that credit just because of the way the rules are structured for the project. And that is both a blessing and a curse for the project. I wish there was some way to make it not so high paced, but there's absolutely no way around it. NASA release data when they release it, and we can't control that aspect.
That is, though, how we work in science too. You know, JWST is going to have a proprietary period. And I know a lot of my colleagues that the day the proprietary period is up on somebody's hard-earned proposal, they are going to pounce on that data and try and publish it if the other team didn't take advantage of their proprietary period and go.
Yeah.
So I guess the throwback to you is that's also teaching good scientific ethics, something we're dealing with in Backyard World as well, has become a part of this process once we realize that if we're going to be teaching people and mentoring them through the process of putting publications out, you also have to understand, check your ego at the door aspect of science as much as anything else. So
absolutely. That's a really excellent point that you raised there. Yeah.
Comets are a little bit different though, because they are named after their discoverer. So I think that might be where some of it comes in. Like when I discover something, there's virtually no chance of getting my actual name on the brown dwarf. But if you discover a comet, you get your name right there.
Well, unfortunately, with our project discoveries, that's how it used to be a few decades ago. But unfortunately now the comets, if you discover them in spacecraft images, they get named for the spacecraft. Okay. Except under certain circumstances where the Minor Planet Center still allow people to use like telescope survey images and give the credit to someone who found the comet in the images, but then they consider satellite surveys to be different. It's a mess, but unfortunately they don't get their name on it, but they do get still kind of credited officially with the discovery of that comet.
I guess I was thinking of people who use their own telescopes to discover comets.
Yeah, that's a different setup. Yeah.
One little add-on to that, Les, though, is that the workaround, because we actually have run into this in Backyard Worlds where people wanted to name something after themselves, because if you find a binary system, it does you can name it, and you can name it. It ends up with your last name can go alongside of the binary discovery in some catalogs. And I noticed that happened in a particularly difficult incident that we had in Backyard Worlds. And it felt it felt like a situation where ego got invited. And the amplification of that to me was when I saw the person was also naming the system in this draft of a paper after themselves. And I was like, no, we don't do that. The catalog people that will put it in the catalog might do it, but we don't do that.
I have noticed too that, you do get that adrenaline rush for, discovering your first object or doing something for the first time. But after that happens for a few times, you really start wanting to get other people to have that feeling. That's kind of your driving factor after that point.
That's wonderful. there's been a question in the chat about pro-am conferences, which kind of is a way to surface some of these things, the culture around a citizen science, or the culture, the kind of professional culture of science, and how do you share that with the public? Have any of you been involved in conferences that bring together professionals and amateurs? And Lynn, if I'm not accurately characterizing your question and you want to bring it forward, please do. And I think we're getting it so that everyone can see everyone.
That was it, Sarah. Thank you.
Okay. If you do gallery view, you should be able to see everybody. Any comments from our panel on good examples of pro-am conferences? And then Bonnie, we're going to get to your question next.
Yeah.
I would say that the American Astronomical Society conference, the general conference, it's for everyone in many ways, educators, people involved in astronomy, but it's not like this is a meeting for professionals only. And so we've certainly had some of our citizen scientists attend, and it's a nice coming together. I mean, the hindrance there is that it's expensive. You have to take a week off from work or a couple days off from work. You have to pay the registration fee. But at that point, I would say, and Marc, you can speak to this too, like the number of citizen scientists that you've seen present at AAS conferences, if you've been seeing that increase, because anecdotally, I've seen it increase, maybe because years ago, I wasn't in a citizen science project, and now I am, and now I pay a lot more attention to the citizen scientists that I see that are there.
Yeah, I think there's so much potential there for AAS to do more with that, and AGU too. I mean, there was a session recently just for amateur astronomers, but so since it was all virtual and it was separate from the science discussions, it was, I feel like there's so much more that could be done. Let me advertise that we're going to have a pub night at the next AAS. You're all invited.
Good place to rub elbows with whoever you'd like to.
And whenever I get to the next AGU in person, we'll do one of those too.
Excellent. Bonnie, you've been so patient. What's your question?
It's been great discussion, and I'm happy to be patient. And as I was waiting, I thought, well, I can kind of put it in the chat and get the thoughts going. So some of the citizen science work, and Lynn, I'm glad you're still on because some of it is under Globe. But I've seen where the first step to me to publishing is to report out what is happening to the community within which you're gathering data. And I'm thinking, going back to some of the previous conversations, that is a great way to build relationship as well. And so I'm wondering if that's something. And then I do have a comment I want to make about the rules for engagement as well. But I want to finish this first.
Okay.
Is Rusty still on? I was wondering if Rusty or Holly, if you've seen that happen somewhere.
Look, there's Holly.
Yeah, I'm here too.
Well, I'll jump in and comment. I know through the International Virtual Science Symposium that does happen with the student projects, but I think, you know, with Globe in particular, it's more something that can work for an Earth-based or place-based activity. I think it would be harder to share with your community about a brown dwarf that you discovered. They might not be that interested or a comment, but I think certainly for Earth place-based, that could be something that is a step.
Bonnie, I think we'd love to hear your comment about rules.
Well, and yeah, the Earth-based was the place-based part was where I was thinking, because it gives them a purpose for having to publish their data, maybe to share with local government, for example, you know, and things like that. But it would definitely only apply to the Earth-based ones. Well, and then the rules for engagement, the ones that SciAct uses, and it's not specifically for a citizen science project, but SciAct as a team has developed a set of norms, I guess I would call it, that we share and all agree to live by. And I think that's an exemplary set. So that's something we could refer to and possibly consider.
Great, good idea. Go ahead.
I was just going to say, I can also speak to that because, you know, we have been running these webinars and we have these virtual part of the citizen science. It's not data collection, but data analysis. We have we sponsor these virtual meet up and do science meetings. And, you know, we have had in the past some misbehaving. And so because of that, I actually reached out to Sarah, and I really like the rules for engagement for this group. And so I asked her about that, and then we have modified that slightly, and we are now using it actually not only for our outreach with Mosquito Habitat Mapper and Globe, but also using it for the NASA STEM Enhancement in the Earth Sciences program. And I think that you just really do need to have these rules of engagement. You know, I've also had, you know, when it comes to like people wanting to publish things, you know, if you're in a science lab, for instance, very often there are rules, you know, about publishing, you know, like who gets the first crack at it, or no one can publish anything without letting other people know that it's going to be published, or, you know, these different kinds of rules from my friends that are running labs all over the world. And you know, we didn't have any rules like that. And we had some situations where some really ambitious students, you know, made some decisions that I thought were a little bit questionable. And so now we have it all written down, you know, what can you publish about? Who do you have to let people know? You know, like a paper got published, for instance, in a real journal. Okay, it's semi-predatory, but, you know, it didn't have the grant information. It didn't have things that should have been in there. And we were completely let out of the process. So we're going to establish some rules of engagement so that people know that, you know, and they're only there to help them, so they don't make mistakes, really, you know. But there's a lot that needs to be learned, and it's you know, the more that we can sort of make possible by setting up rules of engagement, sharing the expectations in advance, I think is going to make everything better. So.
Yeah, good point. And it sometimes can be a challenge for scientists who are kind of swimming in the sea of their ethical practices to recognize what are the most important things to share in a code of conduct or rules of engagement, and what are unnecessary. And I do think borrowing from other people and changing them a little bit can be a good way to start, which is one of the reasons why Marc and I are thinking about templates for these things. And full disclosure, thank you for your nice words about the code of conduct for this series, which is on our website. We used somebody else's and modified it to be useful for us. And then we've also changed it periodically. Every year or so we update it. So I think that's a place where we can all help each other. I am going to stop recording now.